This is day 22 of coding every day until I hit 1K subs. Today I focused entirely on Leetcode, tackling 4 problems that involved arrays, dynamic programming, and some clever logic about maximizing values and minimizing differences. Let's dive in. First up was maximum value of an ordered triplet II. Spoiler alert, the goal is to find 3 indices, I, j, and k, such that I less than j less than k, and the value nums is maximized. If all such triplets give a negative value, we return 0. This is the version, implying a need for efficiency. Alright, here's the solution for the optimized version. The key idea is to iterate through the array just once, thinking of the current element nums as the third element of a potential triplet. As we iterate, we keep track of 2 things: the maximum value encountered so far, let's call it Imax, which could be our nums, and the maximum difference Imax. Nums encountered so far, let's call it Dmax. When we are at index k, we can calculate a potential triplet value using the current nums and the Dmax calculated from elements before k. Then, we update Dmax using the current element as a potential nums, and finally we update Imax using the current element as a potential nums for future calculations. This single pass makes it run in oxygen mononitride time, which is great. Next, I looked at maximum value of an ordered triplet Y. It's the same problem as part 2, but the constraints are much smaller, nums.length less than equals 100, suggesting a simpler solution might pass. So for part 1, given the smaller constraints, the most straightforward approach works. We just use 3 nested loops. The outer loop picks I, the middle loop picks j such that j is greater than I, and the inner loop picks k such that k is greater than j. Inside the innermost loop, we calculate, one time to Klian and Baird, our cods docri, docordivsh with sexti nums, daxti mathli docri, moving cods docri, moving cordivsh bond, nums cods dolts doc, and update our maximum result found so far. Since we initialize the result to 0 and only take the max, it handles the case where all triplet values are negative. This is a brute force approach, running in O(n) cubed time, but it's perfectly fine for n up to 100. And of course, the optimized oxygen mononitride solution from part 2 also works perfectly for part 1. It's always good to see how a more efficient algorithm handles both relaxed and stricter constraints. It reinforces the idea of finding that single-pass logic by keeping track of the necessary maximums, Imax and Dmax, as you iterate. Moving on, I tackled solving questions with brainpower. This one felt like a classic dynamic programming problem. You have a list of questions, each with points and a cost. Solving question I gets you points, but means you must skip the next brainpower questions. You can also choose to skip question I and move to I+1. The goal is to maximize the total points. This is the dynamic programming solution. The core idea is to figure out for each question I, what's the maximum score you can get starting from that question onwards. We build this up from the end of the list backwards. Let dp be the max score starting from question I. To calculate dp, we have 2 choices. 1. Solve question I, get points plus the max score we can get, starting from the next available question, which is, at index I, plus brainpower plus 1. We look this up in our dp array, using dp, next underscore solve, underscore idx, 2. Skip question I. The max score is simply the max score we could get, starting from the next question, I plus 1, which is dp I plus 1. We take the maximum of these 2 choices for dp. By working backwards, when we calculate dp, the values for dp I plus 1 and dp next underscore solve underscore idx have already been computed. The final answer is dp0, the max score starting from the beginning. This runs in oxygen mononitride time because we iterate through the questions once. Finally, I tackled put marbles in bags. This one was a bit trickier to wrap my head around initially. You're given marble weights and need to divide them into k bags according to specific rules. A key rule is that if marbles I and j are in a bag, all marbles between them must also be in that bag. The cost of a bag is the weight of the first plus the weight of the last marble in it. We need the difference between the maximum possible total score and the minimum possible total score across all valid distributions into k bags. Okay, this one required a bit of insight. When you divide the marbles into k bags, you're essentially choosing k1 places to put dividers between adjacent marbles. Let's think about the total score. The score is the sum of weights, first plus weights for each bag. Notice that weights, the first marble, and weights, 1, the last marble, will always be part of the total score, regardless of where you put the dividers. Now, what happens when you place a divider between marble I and marble I plus 1? Marble I becomes the last marble of one bag, and marble I plus 1 becomes the first marble of the next bag. So placing this divider adds weights plus 1 to the total score. Since we need K1 dividers, the total score is always weights 0 plus weights 1 plus the sum of weights plus 1 for the K1 division points we choose. To maximize the total score, we should choose the K1 division points that have the largest weights plus 1 values. To minimize the score, we choose the K1 points with the smallest sums. So the strategy is, calculate all possible adjacent pair sums, weights plus 1, sort them, and then find the sum of the largest K1 pair sums and the sum of the smallest K1 pair sums. The difference between these two sums is our answer. The weights 0 plus weights 1 part cancels out. The dominant cost here is sorting the pair weights, making it O(n) log n. And that's a wrap for day 22. We hit 4 Leetcode problems today, covering optimization with single passes, brute force vs efficiency, dynamic programming, and a neat insight into minimizing/maximizing sums based on adjacent pairs. If you enjoyed this or found it helpful, please hit the like button, subscribe if you haven't already, and maybe leave a comment letting me know which problem you found most interesting, or suggest problems for future videos. Also, if you'd like to support the channel and my caffeine addiction, you can head over to buymeaboba.com, link is in the description. Thanks for watching, and I'll see you tomorrow for day 23.